Welcome. I'm Dr. Owen Anderson, and I'm a professor of philosophy and religious studies at Arizona State University. And I teach philosophy of religion and religious studies about origins. And because of that, students sometimes ask me about articles they'll see. In fact, this one was posted by a friend of mine, and I've been doing a few of these. So I thought it would be good to add this to the list. Have we discovered something new that will make us rethink time and matter and once again realize we don't need God? You'll see the others I've done recently in my YouTube video menu. And all I ask from you for this video is that you subscribe and like the video. Here I'm going to switch over to the actual article and then to some notes I have. And as I go through the article, I'll be discussing the same points I will on my notes, but I'll show you the notes. You can take a screenshot of it that way if you wanted to save those for later. All right, so a brand new theory. Always be suspicious when they say that. Be careful, be watching for clickbait. A brand new theory no one's ever thought of before. Now, I guess I should be fair. This isn't saying that. Someone else might have said that about the article, but this isn't saying that. This simply is going to introduce us to Spacekime theory. Could speed up research and heal the rift in physics. And look at this subtitle. Can Spacekime help us make headway on some of the most pernicious inconsistencies in physics? So you're agreeing there's some pernicious inconsistencies. These aren't just side things. These are deep problems for contemporary I'm going to add materialist physics. So they have some reason to be excited because they think, well, maybe this will help preserve our materialism. Now, a physicist doesn't have to be materialist. And here I'm thinking about physics on the one hand and theism on the other. And of course, most of the physicists in the scientific revolution were theists, but it's often presented today as if there's a conflict between those two. Now, key point here, our linear model of time may be holding back scientific progress. So a new progressive theory of time is going to be what? Looking back to the ancients. And this is why it's humorous if this is put in terms of we don't need God anymore, when the whole article starts with, let's go back to the ancients or to Buddhism or to the people of the Amazon. Well, wait a minute. You're getting your advances in physics by doing that and then making fun of theists who believe God created the world. So let's look at this here. Our linear model of time is holding us back. Space-time theory can help us better understand the development of diseases, financial environment, and environmental events, and even the human brain. So what it's going to be is a statistical model for making predictions of complex systems. Okay, that sounds great. That doesn't help at all with the pernicious contradictions in science. It helps iron out some of the statistical analysis, perhaps. And so what it does is this theory helps us better utilize big data, develop AI, and can even solve inconsistencies in physics. Great. That was the subtitle that got our attention. So again, I already hinted at this humorous first paragraph. The Western concept of linear time is the problem. In ancient Greek, also a part of the West, time was cyclical. And if the big bounce theory is true, they were right. In Buddhism, there is only the eternal now, right? Might go further, there isn't even that. You have to resign yourself to not even existing. Both the past and the future are illusions, as is the self. Got to go further, got to tell the whole story. Meanwhile, the Amandawa, is that right? Amandawa people of the Amazon, a group that first made contact with the outside world in 1986, have no abstract concept of time. So while we think we know time pretty well, some scientists believe our linear model hobbles scientific progress. And maybe by implication, we need to go to one of these. Cyclical. Now, this doesn't change time at all. Time is the measurement of change. And without change, there's nothing to measure, and so there's no time. If you have a cycle, you're still measuring change, it's just that it repeats itself as well as a linear. So this doesn't give us some new view of time. What it does, though, is raise a question about what has existed from eternity. There can't be an eternal line. You'd have to cross infinity to get to the present. So if there's linear time, that goes with saying the universe had a beginning. And therefore, since there are no uncaused events, God the creator. And God, the creator, doesn't exist in time. He's not changing. God is unchangeable. So time, there's no way to measure time. God, hey, remember when God graduated from high school? That was great. And then he got his BA in 3 years. That was fast. Will that be measuring time in a life? And God doesn't have changes, doesn't grow or decrease. So God is not existing eternally in time. God is eternal and then creates, and the creation of the material world and finite minds that go through change is the beginning of time. So then we get to this theory that we're going to look at, Spacekime, where time is two-dimensional as a curved plane interwoven in the fabric of normal dimensions, up, down, left, right, or backwards. And while the hypothesis is over a decade old, Bars isn't the only scientist with such an idea. But what's different with Spacekime is it will allow up to 5 dimensions of just time. And so say, okay, cool. So what is this? The Kaluza-Klein theory, developed in the early 20th century, would state that there might be an extra microscopic dimension of space. So these turn out to be space dimensions, and they're super tiny, so that you can't really interact with them at the normal level. And this was meant to unify electromagnetism and gravity, but there's other forces it doesn't unify. And so because of that, it wasn't adopted. And so keep going here. Today, proponents of superstring theory say there are as many as 10 different dimensions, including 9 of space and 1 of time. So what if there's more than that, of more dimensions of time? And these are data scientists. So they're collecting data and thinking about how to make models for predicting or explaining what happens from what we know already. And what they're saying is their model allows us, let me get the quote. We started looking at data that intrinsically has a temporal dimension to it. It's called longitudinal or time varying data and has many, many names. This is data that varies with time. In biomedicine, this is a de facto standard data. All big health data is characterized by space, time, phenotypes, genotypes. So it's adding in the kinds of things you measure when making a model and suggesting there might be more things to measure. Okay, that doesn't change the problems, the pernicious contradictions the physics faces. Maybe we think these contradictions are different. I'll list those later. So they used a color-coded representations of a complex plane and define Spacekime, or higher dimension space-time, in such a way that agrees with the common observations that we make. That's good. That agreement has very important. So you'd have to explain them. What are these common observations we make that it fits? And the second realization was that since the extra dimension of time is imperceptible, well, hold on. It agrees with common observations and it's imperceptible. It can't be perceived. All right. I mean, in what sense does it exist for physics? Physics measures things that can be perceived by the senses. So after a year, we discovered that there is a mathematically elegant tool called the Laplace transform that allows us to analytically represent time series data as Kime surfaces. Turns out the Spacekime mathematical manifold is a natural higher dimensional extension of classical Minkowski 4-dimensional spacetime. So it's a higher dimension extension of what we already have. It doesn't tell us anything new about time or space so far. Time is still the measurement of change. This might just be adding in something else to measure. Doesn't change what time is. Doesn't tell us what's eternal, what has existed from eternity. Our understanding of the world is becoming more complex, well, and as it should. It doesn't change what time or matter are, but good, we're learning more things we have to study. As a result, we have big data to contend with. How do we find new ways to analyze, interpret, and visualize such data? I guess it means visualize. The space-time theory can help in some pretty impressive ways. All right, what are they? The result of this multidimensional manifold generalization is that you can make scientific inferences using smaller data samples. All right, so smaller data samples, but presumably of more things. I'll call them things because dimensions brings to mind like sci-fi where you go through a door and you're in another world. That's not what they're talking about. More things to measure, but you need fewer data samples. So you still have more information though. And that requires that you have a good model prior to it. Here's the circularity. How do you get a good model? From the right data. And now that you have the model, you don't need the data or not as much data to make the model work. Well, how do we know that enough data was used in the first place to make the model? Perhaps you weren't measuring the right things in the first place. So for instance, we can use Spacekime process representation to better understand the development or pathogenesis to model the distributions of certain diseases. So again, it's about modeling in time, not rethinking time, by taking into account additional factors we may not have in the past. So to give an example from Alzheimer's, the problem of time. Spacekime theory can make us help make headway on some of the most pernicious inconsistencies. Now they'll name them. I'm going to have some different ones, such as Heidelberg's uncertainty principle. Oh, good. Well, how do they do that? Well, it relies on extending the notions of time, events, particles, and wave functions to complex time, complex events, key events, data. And now these were always complex. It's just they may not have realized that. So they're catching up rather than developing something new. So basically working with 2 points of time allows you to make inferences on a radius of points associated with a certain event. So now we're going to solve Heisenberg's uncertainty principle. According to this model, since time is a plane, a certain particle would be in one position or phase time-wise in terms of velocity and another phase in terms of position. That was always the solution. In one sense, it's here, and in a different sense, it's there. In one sense, it's at this time, in a different sense, it's at another time. Yeah, that's always the solution. It's not a direct contradiction. And that should bring humiliation on those who use Heisenberg's uncertainty principle to disprove the law of non-contradiction. Like somehow it disproved something can't both be and not be in the same respect at the same time. No, of course it didn't. So this is like the hidden dimensions of time in Plato's allegory of the cave, or how an X-ray signifies what's underneath but does not convey a 3D image. So it gives us two-dimensional information about even more information that's there and we weren't aware of. It doesn't change that time is measurement of change, and matter is what is extended and without consciousness. So let me go over here now to my notes. We've covered these, and I'm going to review them. Spacekime, a new theory that will resolve the contradictions in physics. Great, you're admitting there's contradictions in current materialist physics, and you're looking to you're looking to ancient models of cyclical time for help. Well, this article didn't bring up God, so I won't bring up God. It makes more accurate predictions. Well, great, that is good, but that doesn't always tell us about reality, because the Ptolemaic system of the solar system made accurate predictions also. So good, it makes better predictions. What's real? Well, it requires rethinking matter and time. No, it doesn't. It almost adds. It doesn't rethink what time is. It just adds more things to be aware of, from a two-dimensional to a three-dimensional awareness or more, 10 dimensions. That's not troubling. Dimensions here, again, does not mean what sci-fi means. It means things to be measured. So we measure only length and height on a two-dimensional piece of paper, or we add in depth for a three-dimensional cube, add in time, changing through time as a fourth dimension. So time is still the measurement of change. That hasn't changed, and matter is still extension and not conscious. Whatever a material object is, however big or however little, it has extension. The problem has been that the materialist says there's only matter. That's when we get into big problems. So for someone to say, look, we're always making progress in science. We're always doing just a little better. And we don't really need God. God is the God of the gaps. And unfortunately, God has been used as the God of the gaps and shouldn't be. But what might be happening here is a confusion of what are called primary and secondary causes. God is not a secondary causal explanation. So when you say, how does the moon go around the earth? It's perfectly fine to say gravity. If you were to say God makes it go around the earth, you'd be thinking of like Zeus rolling the moon through space around the earth. And that's not even God, right? So how does God make it go around the earth? Well, God creates it, gives it a nature, creates natural laws, upholds them in continued existence. Those are all primary cause. Gravity doesn't create itself or uphold itself in existence. But you can't so just like you wouldn't want to say God's a secondary cause, he's rolling the moon around the earth. So too, you wouldn't want to say gravity or any of the laws of physics are the primary cause. Physics only studies the secondary causes. It becomes problematic when it tries to overextend itself. But that doesn't mean that there's only the secondary causes. It just means that physics is limited in what it can study. It only studies the physical. It's in the name. That's why we need also metaphysics and all the many other things we study besides physics. So here we have another example where this is not overcoming, I didn't put this down, the real contradictions aren't simply the Heisenberg uncertainty principle. It's that all is matter. The mind is matter. Matter has existed from eternity. Our highest good is material. Those are the contradictions the materialist scientists will have to deal with. And this doesn't help us on those at all, even if it helps us do some more useful modeling, which is great. We should be happy to hear that. So once again, another article on the advances of science and another response from Dr. Owen Anderson. Thanks for joining me. Until next time.